guidance today? What are we being told? Should we worry about it? Is there any guidance from NIST, for example, or anybody else? Are they telling us to worry about it today, or don't worry about it 2 years away?
So in the US, the NIST have directed the defence, intelligence and other potential state actor targets start to take mechanisms and steps to move away now. In some of those areas and so to protect highly sensitive communications. I think the nature of that sensitivity is open to interpretation. I think in the UK and other jurisdictions, what we're seeing is advice that within a 3 to 5 year timeline, you should be doing something, but it's less clear in terms of a mandate or a directive about what that thing should be. I think I tend to draw on the experience we had from the SHA-1 collision compromise. So effectively, I was in a client organisation when the SHA-1 compromise occurred. And what we found was that we were trying to reactively identify all the places we were utilising that specific protection mechanism and to work out how quickly we could replace them all, effectively prioritising what communications could potentially be left compromised or susceptible for the longest. And anyone that went through that experience decided we'd rather not do that again. And I think a lot of folks at the minute is going actually just sizing the problem. So we talk about the classic PKI infrastructure as an existing mechanism. Do you know how prevalent that is within your? Do you have a feel for how you place that? Because when people talk about that 3 to 5 year timeline needing to take action, that's to complete the action. No one's come out and said if you start in year 3, you will definitely finish within your environment by year 5, because obviously that's highly contextual. So if you look at an extensive organisation that's got very complex systems, multi-year change cycles, and we have a very extensive estate, if that turns out to be a 3-year programme of work, you need to start next year to finish in that 3 to 5 year horizon. So I think certainly, a lot of those organisations just need to start getting a feel for how big the size of the challenge they're facing is, because that will allow them to plan and budget for actually addressing it. And I think that to be able to address that and size it appropriately, you have to have a feel for what you move to. And there's been a lot of conversations around future mechanisms that will address that, so kind of quantum resistant or quantum proof algorithms that could be introduced. But as we've seen with some of the NIST work, they're not necessarily a reliable timeline in terms of when future-proof mechanisms will be available. And what we're seeing is there's plenty of controls and actions we could take today that would help mitigate an issue in the future. Actually, if you can solve tomorrow's problem today and do it in a cost-effective and timely manner, why wouldn't you start planning today?
Yeah, that's great advice. I think there's things actually which may help people who want to know more about this era who are listening or thinking about this themselves. I think as the US is the leading technology place in the world, to look to them always is a good start. And that's not to criticise UK or UK and CSE or anything. It's just that there's such a compelling amount of resources there to apply to it. So to look at not only NIST, but also the CISA in the USA, who have brought out some guidelines, and some of those, many of us have some things, all of us have opinions about the guidelines they've brought out, but they've got to set the guidelines. And also for organisations, what I personally recommend is people have a look at the Department of Homeland Security in the US, who have a very good roadmap for quantum era ahead for an organisation, which is the sort of thing I think we should be mimicking and copying soon in the UK. Because it's exactly what you're recommending, Adam, as a CTO. So you're saying for an organisation, we need to be looking at this in our resource planning and our forecasting, and that's exactly what a roadmap is trying to do for the US organisation. So there's some things where the US are helpful, and I think that guidance, that guideline for there is online if people want to read that and use that. I would say it's worth a look.
I think there's elements of strategy that we're seeing coming out from various organisations and states and departments around how to kind of start to proactively lean into things such as the quantum threat. We know mathematically that the application of symmetric keys into networks start to defeat the quantum threat, because mathematically they can't break those down for X hundreds of thousands of millions of years. So when you start to look at it, a lot of the strategy conversation is around the deployment of symmetric keys. Certain organisations and governments in particular have been deploying those elements to defeat some of these threats for a long time in quite rudimentary ways. And we saw last year the memo from the White House, for example, saying we want all of our NSS networks on symmetric encryption by the end of this year. It starts to summate the challenge, I think, of what's going on. I think you have to stand back and say, if you want to maintain information advantage, and you have to discuss what that information is over your adversarial threats, whether that be state, nation actors, bad actors, sponsored hackers, as we're now starting to see form in the world, then you have to stand back and say, well, what is that information and how do I protect that? Am I worried about my Bluetooth sensor versus am I worried about my data moving between my two data centers that has half the world's financial transactions on it? And then you begin to deploy a strategy that says, what is the art of the possible to defeat these threats today? And I think it's a really difficult challenge that CTOs and the risk board and CISOs have in doing this, because they've got immediate threats around things like ransomware and password protection, pretty basic, all the way up to bad actors coming in and trying to look at how do we rate these networks. I think the other thing is that there could be a quantum computer there today. We don't know. And my view personally is that the first person that invents it is going to be pretty nefarious. Why would they tell anybody you're going to apply that thing and you're going to do your bad actor elements with it, and you're going to do the things that you do for a long time before you make it public domain? And whilst we worry about harvest now, decrypt later, once that thing's there, you're going to worry about harvest now, use now, and you don't have to be really particularly aggressive. You don't have to take things away. You can do pretty terrible transactions by saying, I'm going to deny a service, or I'm going to change the passwords, or I'm going to sit on your network and listen to what you do for a long, long time. So I think it starts to throw the reality of the true threat to operations today, for sure.
And I think it's really interesting because we've talked, kind of touched on the kind of data lifecycle concept. We talked about the kind of the information advantage, and I tend to think about data sensitivity lifecycles in terms of most classifications currently are done kind of at a system level, which all the same problems, so kind of collections of information. But actually within that tend to focus around the sensitivity or vulnerability of information at point of transmission.
Yep.
And actually that understanding around what triggering event or what kind of an elapsed period of time could be before you stop writing about it. So I talked about so commercially confidential information. If you transmit it during a negotiation, that's obviously a very sensitive time. At the point where you've kind of published the outcome of that exercise, you're probably less concerned about it because an element of that becomes common public knowledge anyway. But actually at a system level, if I'm saying you've got long-running transactions, long-running operations, is the granularity there will occur at kind of a record level. Because actually for this piece of information, I might be scared of it being released for, or somebody understanding what it is for the next 7 years, and for other information in 3 months' time. A lot of our existing mechanisms of protections tend to try and employ kind of deploy a blanket broad brush approach to writing protection, saying we protect all things for this given period of time. And actually, I think one of the challenges we've got is the ability to apply some kind of more advanced or superior protection mechanisms with a granularity that can get down to those records and kind of start flowing down through the architecture potential without introducing huge amounts of system complexity.
Yeah.
Because the answer used to be, if you want to apply controls of a kind of a record level database, it became nightmarishly difficult to manage. And again, see a lot of those mechanisms you talked about, symmetric keys, generally people avoid using them because of the perceived complexity and challenges of managing, which we quite often talk about as though managing the alternative and current mechanisms is a lot easier. I've run PKI infrastructure before. It's not the most fun I've ever had. It wasn't a very lightweight activity. It was costing me a few minutes per month. There's quite significant overhead built into those things. And again, I'm currently having to apply them at a system-wide level. Where actually, as a kind of former application specialist, I was always more concerned about records within data sets rather than necessarily the data sets as a whole. And again, I'm seeing a lot of that when we look at things like the move from TLS 1.2 to 1.3 and some of the mechanisms we're using already to protect traffic there, moving down to session granularity, device granularity, record granularity, and the ability to impose controls at those levels may come seems inconsistent with what we're seeing in other technology adoption.
I think we'll come back to the kind of challenge with keying and kind of that part of the encryption algorithm, as we call it. But if you just look at the big picture point, there's more mobility, there's more sensors, there's a hyperscaling of the network, everything links to everything else. And the good old saying of the chain is only as strong as its weakest link is becoming more and more adamant. We're trying to put large compute deployed out to various areas. IoT and OT with the application of machine learning and artificial intelligence is trying to empower digital backbones and digital networks to do a lot of that thought process. So what we're doing in a way is we're actually expanding the threat surface for all of those nefarious cyber activities, and it's both the kinetic attack on the network and it's the non-kinetic effect of what happens from it that's coming to the fore. And sometimes the challenge with cybersecurity is, it's too easy to kind of bury your head in the sand until the event occurs, because it's one of those virtual things that's out there in ones and zeros in this land that you don't see, unlike, something very physical and it's always in front of you and you can see the danger. And I think these are the real elements that's coming on. And, does a cyber attack on your network hold you to the fore, put your business at ransom, and it's generally not an insurable risk and all the other things that happen with it. And I think this is beginning to change. The question always is it changing fast enough to get ahead of the curve with the things that's now possible in this digital metaverse world? So for all the advantages it's going to bring, so it's going to bring very new and very disruptive and real risks that you don't want to be receiving by discovering it. You want to be ahead of it, trying to fight it.